My dear students, in today's video I like to discuss some important topics of signal flow graph, that is signal flow graph terminology and signal flow graph algebra. In my last lecture already I have discussed about the signal flow graph, that is introduction to signal flow graph and its importance and the advantage of signal flow graph over block diagram reduction technique. So let us start the today's topic, that is signal flow graph. Signal flow graph terminology. So signal flow graph terminology is nothing but the different terms used in the signal flow graph and its importance and its main function is called signal flow graph terminology. Generally, the most important terms used in the signal flow graph, that is the term one, that is called node. So let us draw a signal flow graph. This is called one signal flow graph, and let us assume that there is x1, x2, x3, x4, and this is called one node. This is also another node, that is x2, x3, x4. There are four nodes are here, and these are called branches. These are called branch. This is another branch, this is another branch. So generally what is called a node? That is practically in a system the variables, it means the control variables are represented by the node in the signal flow graph. That is the variables represented by nodes in a signal flow graph. For example, in a speed control of DC motor, suppose assume that this is the field control method. So field current, field resistance, etc. as the control variables, and those field current, field resistance, etc. are represented by the node in the signal flow graph, and it is denoted by small circle or teeny circle. It is represented it is denoted in the graph. It is denoted in the graph by teeny or small circle. Small circle. Okay, so you can see here there are four nodes. You can see here there are four nodes. This is one x1, x2, x3, x4, four node. But this node is called input node or source node, and this is called sink node or output node. and this is called mixed node. Mixed node. So what is called input node or source node? The node where no incoming branches are there. It means here the incoming branch is 0. There is no incoming branches connected to the input node or source node. Only outgoing branches like this. We can also draw another outgoing branches. Can draw another outgoing branches here, but there is no incoming branches. Then that is called source node or input node. Similarly, in case of sink node or output node, there is no outgoing branches, only incoming branches are there. This is one incoming branch, this is another, this also another branch, this also we can connect a number of incoming branches, but there is no outgoing branches, therefore it is called output node or sink node. And the node where both incoming and outgoing branches are there, those are called mixed nodes. So next term we will discuss about, that is called branch. Number 2, branch. So this is x1, x2, x3, x4. So this is one branch, this is another branch, this is another branch. And generally the branch gain is denoted by A1, 2, A2, 3, A3, 4. That is 1 to 2, A1, 2, 2 to 3, A2, 3, and 3 to 4, A3, 4. Suppose we can draw another branch here. Then what is this branch is denoted, that is A3, 2. This is A2, 3 because it starts from 2, node 2 and at node 3, therefore this is A2, 3. But here this branch starts from node 3 and at node 2, therefore this is A3, 2. So branch is nothing but which connects two nodes, and the signal can flow only in one direction. In a branch, the signal can flow only in one direction. That is, in this direction signal can flow. In this branch, the signal can flow in this direction. There is no bidirectional flow of the signal in one branch. It means in a single branch, the signal cannot flow in both direction or bidirection. Clear? Okay. This is about the branch. Branch is nothing but the directed line which interconnects two nodes, and in a branch signal can flow in one direction only, So this is about the branch. So next we will discuss about the path, that is called forward path. This is another important term. So let us draw a signal flow graph. This is your x1, x2, x3, x4, x5, and let us assume that this is another branch and this is another branch. This is another branch. This is another branch, and here we can take other branches here. So can take here. This is just assume that. So forward path is nothing but the path which starts from input node and terminates at output node with no node traverse more than once. It means what? So let us find one. This is a signal flow graph, and let us find one forward path. So according to our definition, it starts the input node. So this is the input node and this is the output node. So it starts from input node. It means it starts x1, then x2, then x3, x4, x5. According to it cannot move in this direction because here signal flows in the opposite direction. Therefore, it can flow only in one direction. Sorry, we can move only in this direction, that is in the direction of airwork. Clear? So here x1, x2, x3, x4, x5. This is a valid forward path. This is can say this is a forward path. So to understand the forward path, we can say that x1, x2, x3 and x4 we can also come like this and we can move like this, and it will reach here, that is x5. But this is not a valid forward path. For example, if we consider x1, x2, x3, x4, this is not a forward path because we have started from input node, not reached at output node. We have reached here x4. Therefore, this is not a valid forward path. Again, to clarify about the forward path, if we will consider that is x1, x2, x3, then x4, again we will come like this to x2, then x3, then x4, x5. So this is not a valid forward path because we have we traveled in one node two times. It moves in one node two times. Here x4, x3 is repeated two times, x4 x4 is repeated 2 times. It means we have processed the x3 node 2 times. So that is the mistake. That is, no node traverse more than once. So that is not a valid forward path. So I think the forward path, about the forward path, the concept is 100% clear for all students. So next we will discuss about the loop. So let us consider another signal flow graph. This is another signal flow graph. So loop means that is the path which starts from one node and terminates at the same node with no node traversed more than once. So let us consider this path. This starts from x3 node and terminates at the x3 node. Therefore, this is called a self loop. Then what is called self loop? Self loop means that is the loop formed by a single branch. This is a single branch. The loop formed by the single branch, that is called self loop. And in one node, the loop is formed. So this is called self loop. So if we consider some other loops, like this is x2, x3, x4 and x3. That is, we have started from x2 node we have started and will move in the same arrow direction. We cannot move opposite to arrow direction. So again coming the arrow direction and we have reached here, that is x2. So this is another loop. This is not called a self loop because this forms by 3 branches. This is one branch, this is another, this is another branch, and also by 3 nodes. Therefore, this is simply called a loop. This is a valid loop. If we will consider invalid loop means if we will start x2, x3, x4, x5, again we will come to x3, x4, x2. This is not a valid loop because we have traversed more than once in this node. Therefore, this is not a valid loop. So next we will discuss about 2 non-touching loops. So 2 non-touching loops. That is your 2 touching lobes. This is very simple. This is one loop, that is x1, x2, x1. This is one loop, and this is another loop, that is x3, x3, x4, x5, x3, x3, x4, x5, x3. These two loops are called two non-touching loops. These two loops are not touched with each other, or they are not touched to the same node. Then it is called two non-touching loop. If we will consider this loop, that is x2, x3, x4, x2, and x3, x4, x5, x3. This is called two touching loops. This is not two non-touching loops. So this is about the loops. So thank you very much. The time is over. The rest part I will discuss in my next lecture. Thank you very much.